let's move to installing our Dell server. And as you can see here, it's booting up. It's a PowerEdge 2600. It's got embedded server management, as well as other components, including multiple hard drives and a RAID controller. It's also got two 2400 megahertz processors, or 2.4 gigahertz processors, and it's a dual processor system. So now the hard drives are being detected, and there they are, 3 Fujitsus with 2 LSI logic interfaces and a PowerVolt backplane. So here's the main interface, the main window, and from here we can interact with the kernel and the installation process. We can install by simply pressing enter, or we can upgrade or install in text mode by inserting or entering Linux-based text, which will provide us with a text-based installer. Or you can use the function keys below to get more information, such as providing options, interacting with the kernel, general information, or to enter the rescue mode of the Red Hat Enterprise Linux CD. This is CD 1 of 5 in the set. You may also download a DVD ISO image and install everything from a DVD drive if your server has one. Our server has only a CD drive, so we will install from the CDs. Again, if there's a problem booting your Linux system, then you can press F5 to enter rescue mode and attempt to mount the root file system and repair whatever boot problems you may encounter. Apart from that, simply press enter and this will begin the installation process. So let's move forward. Again, this is a basic installation using CDs. As you can see, multiple drivers are being loaded at this stage after the kernel has performed some initialization steps. And these are generic drivers to provide support for connected hardware. Doesn't mean that your system has those drivers per se, but these are the commonly found drivers on systems. Now, as we've always seen in classic Red Hat fashion, the utility or ability to test the CDs or installation media before moving forward. So here we can perform a surface test of the first CD before using it for installation, subsequently resulting in a failure if there are bad sectors on the CD. If you're confident in your media, your installation media, then simply skip it by moving the arrow key over to the right and moving forward. So we'll skip, and this will proceed with the installation process. If your VGA card has been detected by the installer, the installation program will start in graphical mode. Otherwise, if it doesn't recognize the VGA card, it'll be in text mode. It's found it, ATI Technologies, Rage XL. And now we've got the graphical installation screen. So again, just like with other versions of Red Hat Enterprise Linux, if the Anaconda installer software detects your graphics card, it will then provide graphical support, as we see here. So that means you'll have the ability to use the mouse and the keyboard to interact with the installation process. Release notes are located in the lower left. You click on this just to see if there are any issues or items that may pertain to your hardware. Scroll through it just to see if you've got a wheel mouse, wheel down, as we've got in this particular case, and you'll see there's various information regarding the installation of this version of Red Hat Enterprise Linux. Now we've scrolled down quite a bit, which is why it's taking a while to redisplay. And if there's nothing that's of interest, as is the case for our system, since we've installed it many times with this version, we'll just close, which returns us to the main menu, giving us the ability to move forward. So we'll click on Next. This will take us or advance us to the next step of the installation, which is to select a language to be used during the installation process. The language selection here pertains only to the installation, not to the running system. Some folks may want to install in another language and operate using multiple language support, which is the default support or the default language framework or environment for Red Hat Enterprise Linux. Once you've got the Latin character set install, you have support for all of the Latin-based languages anyway, but for the installation process, you can determine what language you'd like to use. So we'll move forward with English. And now we need to ensure that we indicate the appropriate keyboard, and it is US English, so that the keys match the set that is there. Now we get a pop-up regarding an installation number. If you have a subscription with Red Hat, which is highly suggested, highly recommended, then you'll want to insert the installation number here. The installation number provides you with access to updates to packages, as it tells you here. So, since we'll be using the basic installation, for now we'll skip entering an installation number. But in addition to updates, which your subscription provides, there are other packages that you cannot install without an installation number. Again, if you're using Red Hat Enterprise Linux in your environment, check with your systems administrator for the installation number information. You should have coverage per system so that you're entitled to or have access to packages that are applicable, as well as updates once the system's up and running. And by updates we mean security updates, patches. We'll click on OK to skip installing. It tells you here if you're unable to locate the installation number, you should consult redhat.com. If you skip, you may not get access to a full set. It may result in unsupported installation, and you won't get any software and security updates for the packages including your subscription. So you won't get security updates. You may not be able to get support if you call Red Hat up with help, or asking for help, that is, and you may not get access to the full set of packages included. We'll click on skip anyway, because our intent and purpose here is to simply show you how to march through the installation process using local media. Now you see the hard drives that have been detected on the system. It tells us that there are 3 of them, SDA, B, and C. SCSI disks are indicated using SDA or SD and beginning with the first letter of the alphabet, so SDA through SDZ, whereas IDE TAPI-based hard drives are listed using HDA or HDA through Z. So in this case we see SDAs through C, which means there are 3 disks. There's an option above to remove Linux partitions and only Linux partitions and create a default layout. But if you click on the drop box, you'll see that you can remove all partitions on the selected drives and create a default layout. The default layout is the suggested layout by the installer, which we'll see momentarily. We'll use it again as it works for our intensive purposes. You may also use free space on selected drives and create the default layout. So if you don't want to remove, or you want to avoid removing any of the partitions for fear of losing data, you may select this option, use free space on selected drives and create default layout. But this assumes, of course, that there is free space. If there is no free space, the installation program will complain. You may also create a custom layout, which we'll be doing later on as well. So for now, let's go ahead with removing all partitions on selected drives and create a default layout. Again, there's a link for advanced storage configuration. If you'd like to add, for example, an iSCSI target, which is a remotely accessible disk using the iSCSI protocol, you can do so at this stage. So iSCSI is built in, or iSCSI client support is built in. That is the ability to mount iSCSI targets across the wire. Ideally, you should ensure that you have at least gigabit connectivity to your iSCSI targets. And you can review and modify the partitioning layout after you've elected one of the options here. So the options in this drop box above are basically wizards, minus of course the custom or create custom partition layout. Let's click on next. We'll just work with the 3 drives, and it tells you you've chosen to remove all partitions, which means all data on the following drives. And we'll move forward and tell it that this is okay because there's no data that we'd like to preserve. So let's click on yes and move forward. Now we move on to network configuration. Here are the interfaces that have been detected. Now, this server has 3 network interfaces, 1 gigabit, 2 100 base T interfaces, or 2 fast Ethernet interfaces. ETH0 is the default interface. Unless you indicate a static IP address, one will be assigned using DHCP, provided, of course, there's a DHCP server on the network. If you do want to set a static address, then you can do so below by setting the host name as well as miscellaneous settings, as well as by editing the interface. Or you can have a partial dynamic and static configuration where some items such as the host name as well as gateway DNS systems are derived using DHCP, while other items such as the static IP address netmask are assigned manually. So you can mix and match, or you can blend, but usually for a server class system you'll want to go with a static base setting, which means you would have spent the time beforehand determining which IP scheme is to be assigned to the server, depending on its placement, of course, in your network environment. So let's go ahead and click on Edit. Again, when you click on Edit, you can enable IPv4 support using manual or DHCP static, so static manual or DHCP dynamic configuration. With manual configuration, you're forced to indicate an IPv4 address. So we need to indicate, we said we'd go with 195. Let's specify 192.168.75.195. And we should also be sure that this address doesn't exist on the network before using it, for obvious reasons. The netmask that is to be applied is to be done or to be applied or indicated using CIDR notation. So specify the number of bits, the number of octal bits that are to be enabled. Since we have a standard Class C network, the number of octal bits translates to 24, so it's at /24. This may or may not match your environment. Get from your systems administrator, or if you're the systems administrator, apply the CIDR notation netmask accordingly. Whether or not you'd like to enable IPv6 support, the default is to have it enabled, which uses neighbor discovery, which means it'll find the Cisco 1811 router and self-configure with an IPv6 address. You may also use DHCP version 6 or manually configure a 128-bit IPv6 address in the event that you have a manual environment. It isn't suggested, however, since most environments provide access to a router, such as a Cisco router which supports IPv6, the suggested configuration methodology is to use the router to assign the prefixes and let the host determine its IPv6 64-bit part of the address using its MAC address, as well as whatever other bits, the other 16 bits, whether from 6 to 4 or from other methodologies. The idea, again, is that you want the operating system to automatically assign its unique IPv6 address, but in some environments, in some rare instances, you may want to control the IPv6 address manually. So with that said, we're going to apply 192.168.75.195 with a /24-bit prefix, meaning it will be a 255.255.255.0 subnet mask. So now we've got the address assigned. Now notice we're forced to select the manual option for assigning a host name as well as gateway, primary DNS, secondary DNS, but these settings can be overridden. The installer doesn't allow you to mix and match, but the operating system does. But to avoid confusion, the assumption is if you've assigned an address to an interface, one or more interfaces manually, you'll want to assign host name, gateway, and DNS information manually. So with that said, let's indicate the host's name. We said we would name this system Linux CBT serve 2.linuxcbt.internal. The installer will take care of placing this information into the appropriate files on the operating system. You'll see later on in etc hosts, for example, that the fully qualified as well as the short name will exist in the etc hosts file. So the installer populates the appropriate files, or the files accordingly. The gateway is your default gateway, the way out of your subnet or out of your VLAN, and that's 192.168.75.1. The primary DNS server, as we've mentioned, we've got an all-purpose network infrastructure system which runs DHCP and DNS. It is the SUSE Enterprise 10 box, and it has an IP address of .100. If you recall from our graphics, so it's 192.168.75.100. If there were other DNS servers in the environment, we'd specify it here for secondary DNS, or later on we'll show you how to configure DNS manually, the DNS client manually, using the DNS resolver, and ensuring that the DNS resolver uses those additional DNS servers later on we'll take a look at that. That's the etcresolve.conf file. So let's recap. We have a static association with our primary interface, ETH0. We have not configured ETH1 and 2. We've manually assigned a host name which applies to the system to all interfaces, so it's a global application. It is a global context. We've assigned a default gateway and at least one primary DNS server. Again, we've got 3 interfaces. The Linux kernel assigns the interfaces in the order in which they're detected on your PCI bus. So this ETH0 interface should be the first network interface on the PCI bus, which for this particular server is the embedded gigabit interface. Subsequent interfaces are assigned 1, 2, up to N. So ETH represents the fact that the interface is an Ethernet interface, whether fast or normal Ethernet, or gigabit Ethernet. ETH is the prefix used to cover Ethernet-related interfaces. And again, it applies to 10 megabits per second, 100 megabits per second, 1,000 megabits per second, and subsequent 10 gigabits and so on per second. ETH1 is the second interface, ETH2 is the third interface. But again, for now, we're concerned with ETH0. For other types of interfaces, such as tunneling interfaces, PPTP interfaces, and others, Linux uses the appropriate prefixes such as PPTP, ton for tunnel. They're logical. They make sense. So when you run ifconfig at a later point, you'll see those logical interfaces as they're represented, and when you see those prefixes, you'll know what their purposes are on your system. So with that said, let's move forward. We've spent enough time discussing how to configure a static IP version 4 assignment. We need to select the region of the country that we're in. It knows that we're in New York, but our mouse just happened to be located over Australia. However, the X marks the spot indicating the time zone that's applicable to this system. The system clock currently does not use UTC, so we'll take this off. Usually you'll find on properly configured systems, especially servers, the BIOS is set to UTC. When you set your BIOS to UTC, meaning GMT time with no offset, you can then have the operating system adjust its clock whenever it boots by setting an offset based on the time zone that you exist in, such as UTC -5. Our system clock is set to UTC -5. It tells you here when you hover, use this if you want to automatically switch between normal and daylight saving time. Don't use this if you have other operating systems on this computer which adjust the hardware clock. When we don't have other operating systems, we would like daylight savings time to be affected, which means later on we'll update our BIOS to reflect UTC time and then have the OS change that time appropriately. But modern BIOSes will also update themselves to reflect daylight savings time, which the operating system will get when it boots, and as a consequence, the OS will have the appropriate time. So there isn't much to worry about here. Let's click on Next and move forward. So far we've covered quite a bit. We need to indicate a root password. Let's go ahead and do so. And later on, the security section will discuss how you can tighten the security of your system, including passwords. But ideally, you should set a long enough password, at least 8 characters, and perhaps with varying cases such as upper, lower, and numerical values to make the password stronger. So we've set a password for root. The root account is always the first account created on Linux systems, regardless of distributions, along with other daemon accounts. That tells us here the default installation includes a set of software applicable for general internet usage, such as a web server, and software development category packages. These two groups are important. Software development allows us to compile packages that we will subsequently download off the net. Now, although we're going to reinstall the system many times, it's important that you turn on or enable software development packages if you intend to compile packages. For example, you may download a program off the net that needs compilation, such as a tar.gz file which contains source files for a program that is of interest. Let's say Nagios, for example, the system monitoring application suite. You may download source and need to compile it. If you need to compile it, you'll need a suite of tools including Make, GCC, and others. The software development category of packages includes the applicable tools. Web server includes the Apache web server. It's always useful to have a web server, but may not be for your environment. You need to determine whether or not you need to install the web server. You can further customize the software selection now or after the installation of the operating system using the software management application. If you customize it now, you'll be presented with options regarding the different packages, and let's click on Next so that you at least can see the interface as it is applied. So, we have various categories on the left-hand side. Desktop environments you need to pick, applications, development, servers, base system, and languages. These are the classes or categories used by Red Hat Enterprise Linux. Hasn't changed much since even the version 9 of Red Hat, which is basically Enterprise Linux 3. The default desktop environment is GNOME. This is the default desktop environment for most Linux distros. It's clean, lightweight, and works really well. However, for more of a user-like experience that's comparable to Windows, you may want to investigate the KDesktop environment. We'll go with GNOME because most of our work doesn't or isn't contingent upon having a powerful graphical environment, although GNOME certainly is. Beyond desktop environments, we've got another class, applications. Within applications, we've got subclasses such as authoring and publishing. In the lower area, you'll see the description associated with the class. It tells you that you've got tools such as DocBook, which allows you to convert to HTML, PDF, PostScript, and so on. Navigate to editors tells you that it includes certain editors like Emacs and VI, which we need. And it tells you the number of packages of the total installed. If you click on optional packages, you'll see the ones that are not installed by default. So here we see some are installed and some are not. And they're suggested, or selected that is, based on the suggestions of users. VIM Enhance is installed, which is a utility that we'll use to modify text files later on. Engineering and Scientific has various packages for that community. Games and Entertainment, Graphical Net, which includes a web browser, graphics such as the GIMP. Click on optional packages, you'll see a list. ImageMagick, which allows you to manipulate images, GIMP, which is not installed, and others are made available. Sane, which is a scanner software which allows you to scan locally and remotely. Office Productivity. Click on optional packages, you'll see what's available. This is a document viewer. Sound and video. The system doesn't have a sound card, so most of these packages are useless, which we could just simply turn them off. Text-based net. And if you're interested in Red Hat certification, you should get familiar with the Lynx text-based internet web browser, Mutt for email, and other utilities like TFTP, LFTP, which we'll be looking at. Cadaver, which is a WebDAV client in the event that you want to interact with WebDAV-capable servers, and another Lynx-like text mode browser, eLynx. All are important tools to help you get through the exams, as well as to be able to connect to HTTP resources without a GUI environment. Let's move to development. You'll see, because we indicated that we want the software development packages installed, a great deal of them have already been checked, minus, of course, what you see, such as Java development, things related to KDesktop, and so on. But for X and for basic development tools, we've got them, which includes Make, GCC, so on and so forth. In the servers section, you'll find various classes of servers, such as infrastructure servers like DNS, FTP, legacy network server, which tells you it includes the older protocols like RSH, Telnet, which we try to avoid like the plague because they're clear text based, which means they transmit your credentials in the clear, and it means middlemen or sniffers or people in between can intercept your credentials, which you don't want. Mail server. These are packages which allow you to function like a mail server. Postfix, SendMail, IMAP, so on and so forth, which all of which we look at later. MySQL, we look at later on. Network servers. We've got more infrastructure components, DHCP, Kerberos, and NIS. These are commonly used network infrastructure services that are made available with this distro of Linux. Whether or not you'd like to run a news server, a PostgreSQL database server, printing support, which is provided by CUPS or Common Unix Printing System, server configuration tools, which are tools which allow you to configure, graphical tools that is, which allow you to configure your server in a graphical setting. The web server, which we selected earlier on, is now selected, which includes, of course, the Apache web server. There are many other modules which have not been installed, which we can install later on depending on whether or not we need support for them. But the common ones like ModPerl, ModPython, PHP are all installed. These are the common tools. Tomcat is not installed. Squid is installed. That's a proxy server. Webalizer, which allows you to parse your logs, is installed. So we have some things here that are of interest. And last but not least, beneath servers, we've got Windows File Server. This is the Samba server. If you click on this, your server will become a Samba server, which means it will appear to Windows clients and Samba clients to be a Windows server. There's a base system group, which includes some administration tools, most of which are installed, 13 or 14, and other tools. Languages. What support you'd like once the system's up and running. Scroll down, you'll see what's currently selected. There are all sorts of languages across the world, and they're supported by most OSs, such as Red Hat Enterprise. If you need additional support, go ahead and select it, and then you'll have it available. And perhaps if a user uses your system, they can customize their environment to use the language that you've provided support for. With that said, without spending too much more time, let's move forward in installation so we can get this basic installation over with. Again, all along we've been using CD number 1 of 5. We've burned all 5, but we haven't used all 5, and generally we don't use all 5. And optionally, if your server has a DVD reader, then just download the ISO image from redhat.com for the latest version of Enterprise Linux, version 5. That is the DVD image. Again, you need a subscription or you need to pay for the trial program in order to gain access to the ISO image. And in order to gain access to updates, which includes patches, which includes security updates for versions of programs installed in your version of Red Hat Enterprise Linux, you will need to have a subscription, a valid subscription with Red Hat. So keep that in mind. Whenever you use an enterprise class software such as SUSE Enterprise, Red Hat Enterprise, you must have a support contract in place or a subscription in place, and you will then benefit from any updates, patches, security patches or updates, and that will keep you free of or reduce your risk of exposure to certain exploits. So now dependencies are being checked. The underlying technology used by Red Hat Enterprise is called RPM, for Red Hat Package Manager. That technology is used to resolve any dependencies based on the packages that we've selected. Many Linux packages, regardless of distribution, rely upon other packages. So for example, the author of one program may rely upon, let's say, OpenSSL development packages to provide cryptographic support. And the cryptographic support will not work unless OpenSSL or TLS or some similar framework is installed. So in other words, there are many dependencies, many cross-dependencies that frameworks like RPM and Debian's apt or aptitude have to keep track of. Many dependencies. Again, Linux distros include thousands of packages, many of which have dependencies on other packages that may or may not be installed in your system. Over the years, those dependencies, the management of those dependencies have gotten much easier. There was a time, as recently as 5 years ago, where you could spend literally all day or more trying to solve or meet the needs of various packages in order to get them to work. It's not necessarily a thing of the past now, but it's not as difficult. Now, this tells us here that we can click Next to begin the copy process. In addition, in classic Red Hat fashion, beneath root's home directory /root will be a file install.log. This file contains information regarding the installation process, errors, successes, so on and so forth. a kickstart file beneath root named Anaconda, and this is again classic Red Hat fashion. Anaconda-ks.cfg will be created in this directory in the event that you want to mirror this installation to other systems in your environment. So in other words, all the selections that we've made thus far will be reflected in the Anaconda-ks.cfg file. So keep that in mind, as when we look at the Kickstart installation process, we will show you how you can reference a file and have these options pre-selected for you so that we can install multiple systems, or even a single system, much quicker. We'll click on Next. As you can see, the release notes are still available. Before we get into the installation process, we're forewarned. We're told that we'll need disks 1 through 3, not 1 through 5, but 1 through 3. It tells us if you need to abort the installation and reboot, please select reboot. In other words, if you don't have all the media, or you don't have enough space, or if there's some sort of problem, or if you've got second thoughts, then now's your time to exit. Or you can go back and make changes. You can always navigate to a previously selected area or previously explored area and make changes. Otherwise, if you're confident, move forward by clicking on Continue. Once you click on Continue, we move into the process that you see here. The file systems will be formatted. They'll be defined and formatted. By defined, we mean using Parted, which is a dynamic partitioning utility. The file systems will be created, and then using utilities such as Make2FS, they'll be formatted using the ext3 file system or Riser or whatever file system you've indicated. We've gone ahead and used the default file system layout, so as a result, the Make2FS will be referenced. Now, in true Red Hat fashion, there are multiple screens maintained that you can access to see what else is going on with the configuration using the Control-Alt sequence, Control-Alt F1, so on and so forth. So again, our file system, this is the root file system in this case, is being formatted. The default layout creates a large root file system, and that's why it's taking so long to format the file system currently. So we'll just wait this out. And momentarily we can hear the disks spinning here very rapidly. They're SCSI, so it should move pretty quickly. There's the boot file system being formatted, and the install image is being transferred to the hard drive. And we should be moving forward into the copy process momentarily. So again, the installation process has not changed drastically since Red Hat version 9, or going back to about 2002, 2003. It's roughly the same, plus or minus slight differences. It's smoother. The detection of hardware is much smoother, especially your graphics card and USB mice. Like, for example, in this case, I'm using a USB mouse connected to the PowerEdge 2600 system, whereas years ago, I would have shied away from the USB mouse because of the lack of support in the installation process. But now USB mouse support works flawlessly. The image is still being transferred, so this will take a little while. And now it says it's starting the installation process, at which point we're going to see files being installed rather rapidly. And our screen's changing. As mentioned, using the Control-Alt sequence, using F1s through 6, you can access other useful screens while Red Hat is being installed. Red Hat Linux is being installed. Control-Alt F1 all the way through F6. The screen that we're currently on is the F6 screen, or the graphical screen. Whereas when the system was booted and up and operational in production mode, Control-Alt F1 or Control-Alt F1 through F6 represent 6 text-based consoles, and Control-Alt F7 accesses the lone graphical console. So there's a slight difference between the way the consoles are presented during installation and when the system's up and running for production. In production, you've got 7 windows that are accessible using Control-Alt F1 through F7. But during installation, we have access to 6 windows, Control-Alt F6 providing us access to the current interface. Now, rather than spending time waiting for all the files to copy, as you get the picture, we're going to pause and resume towards the end of the installation. So here you see the packages being copied, and when we near towards the last quarter of the installation, somewhere in this vicinity, we'll resume, reboot the system, complete the installation, and then move on. So at this stage we're in the last quarter of installation, roughly 2 minutes remaining, and the system will reboot after we instruct it to, and present us with a new Red Hat Enterprise installation, which will include, of course, the anaconda-ks.cfg file to facilitate subsequent Kickstart-based installations. And again, Kickstart is a method of installing the operating system without being prompted, so an automated promptless installation, unless of course you've missed some of the options. It's a way to reduce the number of prompts and help automate the installation. So now we're rebooting, and the system checks will take place as usual. It's just a quick dismount from the installation process to this screen, and after the BIOS has checked the installed physical components, then it will be presented with the Grand Unified Bootloader. So typical boot up sequence includes the BIOS, checking your local hardware, determining which disk is the boot disk, whether it's a CD-ROM, USB device, floppy disk, or hard drive. And in this case it'll be a hard drive, as we have ejected all of the CDs. Once it finds the bootloader, which it will momentarily, it presents the menu. And here's the boot menu. It typically displays at 640 by 480. Once we've made the selection, it will return to roughly 720 by 480. So it's a grub menu, version 097, and we can modify it by pressing E to edit, or modify the kernel arguments by pressing A, or booting to a command line, or simply pressing Enter to boot the default option. This is the default option, Red Hat Enterprise Linux with the version of the kernel. There is no backout version, although we could modify the grub startup process, which we'll take a look at later on, which will allow us to insert one or more additional items and boot from them in the event that we need to boot the system in a different fashion, such as single user mode and so on. So at this point, if we press Enter, then we'll move on to the new resolution. So here's the boot up process. File system is ext2fs. And if journaling is turned on, then we will be able to make use of quick recovery. The root file system is the first hard disk partition, so HD0, 0, so the first hard drive of the 3 SCSIs. And now various services are booting up. If we press the spacebar to show details, we'll see them. These are the different services and initialization steps, such as setting the host name, starting NFS, RPC, and different applications, Yum, to update the packages. And now we're propelled into a wizard. This is a first-time wizard, so you won't see this on subsequent boot ups. It welcomes us. Let's click forward. We need to agree to the license agreement, otherwise we'll be unable to use the operating system. Whether or not a firewall is enabled, it's enabled by default, and it permits SSH connectivity. Initially, I like to start off with disabled and then manually disable the ports that are not necessary, or enable ports that are necessary. So we'll disable the firewall and move forward. Otherwise, the default configuration, as you saw, will permit only SSH connectivity. You can turn on other connectivity such as FTP mail, etc. However, the default is to enable SSH. So let's disable the firewall for now. We do look at IP tables in the security section. And it tells us the security level will be lower, and we'll just indicate yes. What SE Linux policy you'd like. Enforcing is set to the default, or as the default. Permissive and disabled are other options. And it tells you above that it provides, SE Linux that is, provides a finer grained security over the system by setting policies, extended attributes, and so on. Tells you the states it can be set up in, disabled, which only warns about things which would be denied, so you have a sense for how you could implement SE Linux. A fully active state, which is the enforcing state. Let's go ahead and just leave it on disabled for now. We'll click on forward and tell it yes. It tells us that the system needs to be relabeled. And there's a crashing dump utility which allows us to capture items that have been dumped by the OS if the system crashes, in particular by the kernel. It tells us kdump will capture that information, and it can be used to determine why your system crashed. For mission critical applications that can afford little to no downtime, it's a good idea to enable the kdump facility. Just go ahead and turn it on, enable kdump. You need to indicate the kdump memory, so the amount of memory that kdump can use to capture this information, and the usable system memory. It is resource intensive, by the way, so the more memory you have, the better. Otherwise, disable kdump. And if the system's not a mission critical system, then disable it altogether. It tells you here that changing the settings requires rebooting the system so that the memory can be reallocated so that kdump can get a portion of that memory, and asks us would we like to continue and reboot the system after first boot is complete. We'll just say yes. Now we need to set the date and time, and that looks correct. Next window we have network time protocol. We can enable a network time protocol. Lookup list, we'll turn it on here, and it references pools of servers, Red Hat based servers, under pool.ntp.org. You can also add NTP servers in your environment by indicating, for example, we'll indicate the IP address of the all-purpose infrastructure server, which provides NTP services again as well, and that's a 192.168.75.100 system. So this is an internal system that can be added to the list of systems. When you press enter, it checks to see whether or not the system is reachable, whether or not NTP is running on the system. If it doesn't find it, it will come back momentarily and tell you that there has been a problem finding it. Now that can be for one or more reasons, including, but not limited to, an inability to connect to the network. So we'll just go ahead and tell it yes anyway to keep it there, because we know the server is an NTP server, and we'll resolve the network connectivity issues later. And here it's going to try to connect to the NTP servers, and NTP has built-in redundancy and facilities to handle the inability to connect to servers. So it'll connect to only those servers that it's able to connect to, all built into the protocol. Here we can register the system. We'll tell it no, not at this time. Again, doesn't suit our intents and purposes at this particular time. Tells us or prompts us with whether or not we're sure we don't want to connect to the Red Hat network because of the following: security and updates, downloads, support, compliance. We'll just say no thanks at this stage. But again, for your production systems, definitely register them with Red Hat and pay the subscription fee. It tells you won't be able to receive software updates. There are other updates online, Yum repositories that you can use to update your software, but you won't get updates from Red Hat directly unless you have an active subscription. Let's click on forward to move to the next step. Now we need to create at least one user can be used, just like with other Linux distros. So we'll create a username Linux CDT with a default password. And if you want to use network authentication such as Kerberos or NIS, then you click on the network login button and indicate the realm and applicable information. Now here it says it's detected an audio card, although it's a server that shouldn't have it, and I don't think it actually does, so it may be misdetecting the audio card. And now it tells us the system must be rebooted, and then we'll finally be in our new environment. So let's click on OK. Now we're rebooting again. So the backplane and server detection process will continue as usual. We'll be presented with the grub menu, the handoff from the BIOS to the grub bootloader, and then from grub, the setup of the initial RAM disk, then access to the base file system, then a subsequent load of drivers necessary to access the remainder of the file systems, and then a subsequent boot of the operating system, which includes setting up the host name, IP address, IPv6 information if applicable, amongst other things such as services. And Pixie boot. And we're booting again after the main menu. UDEV, Universal Devices, is starting. We've got the full graphical environment with services coming up, most of which are okay. One just popped by with a warning. And now we're up in full graphical mode. This is the interface which allows us to log in and make use of the system. Again, there are multiple consoles available, Control-Alt F1 through 6, and this is Control-Alt F7. So if we log in as the user, Linux CBT, the non-privileged user that is, we'll be able to access the system. In addition, we should also note that there are options below such as languages. You can change the language that's used to access this interface. Many languages are supported. We'll cancel. Session information. You can log into different desktop types if they're available, or if for some reason GNOME doesn't start, a failsafe terminal, or just use the last session if GNOME or your desktop did start. You may restart the system by clicking on Restart, and since we're at the console it doesn't prompt us. We also shut down the system by clicking on Shutdown. In both cases you have to, of course, confirm. So let's log in. And now we're being propelled into a full Red Hat Enterprise desktop. In this case server, but it's a desktop that's useful. So we can interact, open a terminal, look at the layout of the file system using df-h, and as you can see our disk was configured into a logical volume presented by DevMapper Volume Group 0, Logical Volume 0. 98 gigs were provisioned, 2.5 are used, or were used in this installation, 91's available. So the default file system layout creates one large root file system, a small, in this case, 100 megabyte boot file system to store the kernel and other boot-related items, as well as a swap partition, which we can reference using the swap command, but we'll look at later on. So we're up and running, and this is a full-fledged system. Let's check its IP configuration using sbin IP, or ifconfig that is. It is set to 195. We can try to communicate sending 3 packets out to perhaps the default gateway located at 1, and in this case it doesn't respond. So chances are either the wrong interface is plugged into the wire, or the interface is plugged into the wrong VLAN, which we'll sort out later on. So we've installed using the CDs 1 of 5, or the CDs 1 through 5 using 1 through 3. We're up and running. We're going to look at other installation methods momentarily.